Good evening, sir.
Today's topic is left part of chemical kinetics.
Yes, sir.
Yes, let me start. Briefly introduce yourself.
My name is Avantika. I belong to Hisar. I have completed my schooling from Hisar and I have completed my BSc M.Sc dual degree course in chemistry honors from Guru Jambheshwar University of Science and Technology, Hisar.
Last day we have discussed last topic in chemical kinetics. Order.
Order. Yes, sir. Order.
Order completed all third order.
Yes, sir.
Yes, today new topic is activation energy. What is activation energy? What the main application of activation energy in chemical kinetics? Explain.
Sir, activation energy is the energy which is required by the molecules to attain the threshold value so that the so that it can the reactants can convert into product. It is the minimum amount of energy which is required for the reactant molecules to convert into product to attain the threshold energy. And the in case of and in chemical kinetics we study the rate of reaction. So if the activation energy is lowered, the rate of reaction is increased. And if the activation energy is increased, then the rate of reaction get decreased. And activation energy
What is threshold energy?
so threshold energy is the energy which which the reactant molecules have to cross to convert into products.
Explain on board. What is actual energy? What is activation energy? What is threshold energy? Explain from graphical representation. Is first note on topic name is chemical kinetics. Then start.
Sir,
Yes.
if we draw the graph of exothermic reaction, this is the energy of reactants. This is the energy of products. And this is the threshold energy. The energy of reactants plus the energy of activation is threshold energy. Therefore, activation energy is the minimum energy which is required by the reactants to attain this threshold value. This is activation energy for reactants, and this is the activation energy for products. And this is a exothermic reaction. So here the energy of products is less than the energy of reactants, and the activation energy of products is more than the reactants. If we draw the graph of endothermic reaction, then the energy of reactants is more than the energy of products, and activation energy of products will be less than that of activation energy for reactants. And if in a reaction this reactant is converting into product by this particular amount of activation energy, and if we add a catalyst, then this activation energy will be lowered. So if in starting the activation energy is this, then the activation energy will decrease when we use catalyst.
Yes. What the difference between exothermic and endothermic reaction?
Sir, in case of exothermic reaction, heat is released, and in case of endothermic reaction, we have to provide an energy to complete the reaction. In case of exothermic reaction, delta
Any limitation of activation energy in chemical kinetics?
sir,
Yes.
sir, in case of
No problem. You look
sir,
them.
like
Yes, yes.
sir, like if two molecules are colliding and one molecule is being activated, then to obtain this. This is known as activation process, and if this molecule collide with another simple molecule, then it loses its energy. So it is a it is not a permanent process.
कुछ पॉइंट इसके स्टडी कीजिए आप। एक्टिवेशन एनर्जी जितने भी टॉपिक्स हैं उनकी लिमिटेशन तो होनी चाहिए, इंटरव्यू में वही पूछे जाएंगे। और जो मैंने क्वेश्चन शेयर किए थे इंटरव्यू ट्रांसक्रिप्ट ग्रुप में, उनके आंसर आप तैयार कीजिए जो आपके टॉपिक है। सब नहीं करने, जैसे आपके टॉपिक है कोऑर्डिनेशन है, केमिकल काइनेटिक्स है, तो जो टॉपिक आपके मिलते हैं उनके आंसर आप दीजिए मुझे। वो मैंने अभी 4 शेयर की थी, बाकी मेरे पास और भी है बहुत सारी, वो भी शेयर कर दूंगा। उनके आंसर
So
एक्सप्लेन होने
group
चाहिए 100 to 150 वर्ड्स में, ज्यादा से ज्यादा एक्सप्लेनेशन होनी चाहिए, है ना। आपने आइडिया लग गया होगा पीआरसी में कैसे क्वेश्चन पूछते हैं।
ग्रुप में शेयर करेंगे सर।
हाँ, ग्रुप में ही कर देना या मुझे कर देना, कोई दिक्कत नहीं, ग्रुप में कर देना तो ज्यादा सही रहेगा। उससे आइडिया लगता है कि आप आंसर देते हो, क्योंकि और लोग भी देखते हैं ना। अगर आप गलत आंसर दोगे तो दूसरा क्रॉस क्वेश्चन कर देगा, तो उससे आपको ही बेनिफिट होगा। ठीक है। नेक्स्ट पॉइंट इज अर्नियस इक्वेशन। व्हाट इज अर्नियस इक्वेशन? व्हाट द मेन एप्लीकेशन ऑफ अर्नियस इक्वेशन इन केमिकल काइनेटिक्स?
Sir, Arrhenius equation is given by K is equal to AE minus EA by RT. Here K is rate constant and A is called as Arrhenius parameter. And in when we study the collision of molecules in collision theory, then the Arrhenius equation has application in it. Like if like we in
Yes, explain on board graphical representation of Arrhenius equation. How to determine of activation energy value from Arrhenius equation.
Arrhenius equation is equal to AE minus BA by RT. So here if we take log of this equation, From here we got the Arrhenius equation in form of log, that is log K is equal to log A minus EA by 2.303 RT. If we have to calculate the rate constant at two different temperatures, then we use the Arrhenius equation. Let there are two temperatures T1 and T2.
Yes.
Then we can calculate the rate constant at two different temperatures by log K2 by K1 equal to EA upon 2.303 R 1 by T1 minus 1 upon T2. We can further write it as from here we can find the this is the equations of Arrhenius.
Yes.
And if draw the graph of this equation, then here we will write log K is equal to log. So from y is equal to mx plus c, here y is log k and log a is intercept. And here we will got the decreasing slope, and the value of slope will be minus EA upon 2.303 R. So this is the graph of log K versus inverse of temperature.
Log versus temperature, yes. Or
Yes,
concentration versus time, that graph.
concentration versus time in case of zero order or first order, sir.
Any limitation of Arrhenius equation?
Limitation.
No, I will send you on WhatsApp. Yes, no problem. Next topic is catalysis. What is catalysis?
So catalysis is the process of using a catalyst for changing the rate of a reaction. We can increase or decrease the rate of a reaction by using a catalyst. there are two types of catalyst. One that promotes or fast the rate of reaction, and one that is inhibitor catalyst that decrease the rate of the reaction. The promoter catalyst, which enhance the rate of a reaction, doesn't participate in the reaction, but it decreases the activation energy of the process. The catalyst works by combining with the reactant molecules at temporarily, and the that transition or state is temporary, and it is responsible for decreasing the activation energy. And after decreasing the activation energy, catalyst will the catalyst will that is combined with the reactant temporarily de- will de- will remove, and the rate of reaction will be increased.
One example is Haber process. Yes, no.
Yes.
N2 plus 3H2NH3. Iron, molybdenum. Molybdenum is promoter. What the role of promoter in any catalyst?
So promoter will help the help to decrease the activation energy, and if we use there are many factors that determine the rate of the reaction, and one factor is particle size. If the if the if we are using the small particle size which have greater surface area, then that will absorb the reactant molecules more, and it if the reactant molecules are more absorbed, then the rate of reaction will increase.
Yes. Any limitation of catalysis?
So catalyst only increase or decrease the rate of reaction, but it has no other important role in determining the feasibility or spontaneity of a reaction. And for a catalyst to work, we have to uh, provide optimum temperature and pressure.
Yes, good. Next new topic is steady state approximation. What is steady state approximation and what is the main application of steady state approximation in chemical kinetics? Explain.
So steady state approximation is used for the intermediates which have very less lifetime, which are uh, steady state approximation is used for unstable intermediates. the concentration of concentration of any reactant becomes constant, that its rate of formation and deformation is same. So it is in case of then the rate of formation minus rate of formation will be equals to rate of deformation, and by if there is a complex reaction, and the if we have to, like, rate should only be given in terms of stable species. So if we find some unstable intermediate, then we have to remove that unstable intermediate. So to remove that unstable intermediate, we use a steady state approximation to find the rate in terms of stable species.
What the main purpose of steady state approximation in chemical kinetics? Any 1-2 point?
Sir, with the help of steady state approximation, we have found uh, the uh, we have found the rate in case of enzyme and enzyme substrate. When enzyme is combined with the substrate, then it will convert into enzyme substrate complex, and it can either uh, convert back to enzyme and substrate, or it can convert into product. In here the here with the help of steady state approximation, we can find the maximum rate for combining of substrate with the enzyme.
Yes. Next, what is equilibrium approximation? What is the difference between steady state and equilibrium approximation? Explain.
Sir, in equilibrium approximation is used for the reactions which are in equilibrium, or we can say equilibrium approximation is used for reversible reactions. And we can find K equilibrium from this reversible reaction by applying equilibrium approximation, and steady state approximation is used where unstable intermediates are present, like mostly radicals are unstable intermediates.
Yes. And difference? Any 1-2 point? Difference between both?
So first difference can be that equilibrium approximation is used only for reversible process, which can be stated in a which can be represented in one step, and steady state approximation is used for a complex reaction where rate is determined by the slowest step, and we have to find the rate of that species in term of that stable species.
Yes. Steady state approximation is slow rate determining steps. Doesn't exist. Yes, no. Intermediates, only one. Equilibrium approximation, so many intermediates. Rate determining step is exist. Is a 2 point. Major 2 point difference. Next is what is Lindemann theory? What the main application of Lindemann theory is in chemical kinetics?
Sir, Lindemann theory of unimolecular reaction, we uh, can be explained as like if we have taken a container in which many molecules are present, then there are chances that suppose A molecules are present in that container, then that one A molecule can combine with the another A molecule and get activated. So this process will be known as activation process, and from here after activation process there are two probabilities of that molecule. Either it can lose its energy to the another A molecule, and again loses its energy. This will be called as deactivation process. And in the other probability is that activated molecule can convert into product. If the activated molecule convert back to the simple molecule, then it is called as deactivation process, which is more favorable at high pressure. And if the activated molecule converts into product, it is known as decomposition process, which is more favorable at low pressure. And deactivation process follow at a low pressure. This will follow first order kinetics, and at high pressure it will follow zero order kinetics.
Yes, high pressure and low pressure. Yes, can you draw graphical representation of Lindemann theories? High pressure, low pressure, rate versus concentration, rate versus time.
Yes. Let one molecule A plus A star plus A. This process is activation, and this process is called as deactivation. A star can convert into product. This will be called as decomposition. So from Lindemann theory, B rate is equal to, let this is K1, this is K2, and this is K3. So here rate will be K3 A star. But here A star is also in this equilibrium reaction. So we will have to eliminate this to so from here we will K1 A2, that is rate of formation of A star, is equal to K2 A star A, that is rate of deformation of A star, plus K3 A star. So here we will find this A star as K1 A2 by K2 A plus K3. So from here we found out the rate for Lindemann theory of unimolecular reaction. Rate is equal to K3 K1 A2 upon K2A plus K3. So when pressure is low, at low pressure, this K3, that is decomposition process, is favorable. So at low pressure, K3 is more than K2A. So when we because K3 is more than K2A, so K2A will be negligible, and in this equation, from here this equation we will find the rate for decomposition process, that is rate is equal to K1 A2. So this is the y is equal to mx square equation. From here we can draw the graph between rate versus concentration of A as hyperbola. This will be the graph for decomposition process. And for deactivation process, K2 will be greater than K3. So from deactivation process, we will get rate K3 K1 A upon K2. When we draw this is the y is equal to mx kind of equation. So when we draw the graph between rate versus concentration for deactivation process,
Yes, good.
it will be a linear graph.
Yes, good. Next day we will discuss left part of chemical kinetics.